Welcome back, everyone, to another episode of Build What's Next. I'm your host, Jason Rome, leading digital strategy and solutions here at Method. Joined by an esteemed panel today. First, my co-host here with me in Charlotte, Raj Sethi, who I've worked with and learned so much from over the years, who is our SVP and go-to-market leader for AI and SDLC. And someone who every time we talk, I learn something new, and I'm excited for you all to learn from today. And then we've brought in two of our partners from ISG who have been writing and learning a lot about the ecosystem and trends in AI, cloud, and adoption in the SDLC. Ashwin Gaidhani, who is a research partner and lead analyst and subject matter expert when it comes to enterprise services based in Hyderabad. And Tapati Bandopadhya, who is an expert leader based in Irvine, California. She's been working in AI since 1997, and we're going to get great views from her on the past, present, and future of AI and bringing those insights in. So stick around today. We'll be talking about, fact fiction in terms of in the AI, SDLC, and PDLC, about ROI. Where is their return? Where is there not? What do we expect to happen in terms of the costs? Where are the tooling going in that space? We're going to talk about adoption, change management, and the environments. How do you curate an environment at your company for your employees to work with? And then we'll get into some specific use cases around legacy technology, modernization, around testing, around elaboration, with the goal of you walking away today with a couple tactical things that you can hopefully take back to your organization to start improving now as well as building towards the future of what's next. So enjoy the show.
You are listening to Method's Build What's Next Digital Product Perspectives, presented by Global Logic. At Method, we aim to bridge the gap between technology and humanity for a more seamless digital future. Join us as we uncover insights, best practices, and cutting-edge technologies with top industry leaders that can help you and your organization craft better digital products and experiences.
Well, welcome in, everybody. Really excited for the conversation we're going to have today. I think one of the leading indicators of a good podcast is when you go to prep for the podcast and you actually should have just recorded the prep because you have the whole conversation. And I think when we got this group together, that was the conversation that we had. So again, I'm joined by my colleague Raj Sethi today in the room here, who leads our go-to-market and SDLC for Global Logic. Dr. Bandopadhya, who is an expert leader, as well as Ashwin Gaidhani, analyst from ISG. And we're going to be talking about the end-to-end adoption of SDLC with AI right now. It feels like not a day goes by where some prestigious university doesn't release a report that says, we're seeing really high ROI, we're seeing no ROI. And I think our goal here today is to try to find the way in between that and separate the truth from the lies. And really, we're going to focus on three things. One is this concept of ROI. And I think we're going to hit on both the R and the I today. So what is value? How should companies be thinking about value now versus in the future? But I think what does investment look like? There's been some interesting articles on less is more that we'll talk about in some of these smaller models. And what does the expense look like going forward? The second thing that we want to talk about is share some observations of what's blocking adoption, what's hurting companies from using these tools from a process perspective of are we evolving our operating models to be able to adopt these new tools. And then finally, just change management and the human side of these things. What have we seen? What have we learned in terms of getting the employee buy-in, creating the right environment around the employees in this economic times that we have for GenAI adoption in the PDLC? So, Raj, I'll turn to you first. We've had a lot of conversation about this. We do a lot of work with companies even before AI on their operating model and end to end. What have you seen so far? What are some of the big observations around what have been the roadblocks to companies that want to take advantage of these tools in the market right now?
Well, I think there are a couple of areas when adoption comes into play, right? We work with lots of companies that have their own processes, and we typically adopt them. There's not much room or wiggle room that we have to redesign their processes. And often that's one of the problem areas when it comes to adoption. The understanding a lot of organizations have is that, I sort of now came up with another an analogy around. It's like buying the Peloton and thinking that once you bought it, you're going to be fit.
That's not how
Uh,
that works, huh?
yeah,
Oh,
just
okay.
nah. I mean, it becomes an expensive a coat hanger eventually, because unless and until you really redesign your processes and start looking into where do you bring the tool, it's more really about tool augmentation than anything else. And I think often organizations really struggle with that. And, we've seen stories where enterprises have adopted the top tools out there, and, the claim is no ROI.
Yeah.
And it's almost like they give the tool to the same team running the processes same way, and not getting any ROI. The key aspect though is really, if you've got a road with a lot of stop signs on it, you're just not going to be able to accelerate. And these stop signs are really human orchestration stop signs. Whether it is about PI planning, how do you groom your backlog? It's how do you ensure that you do your release management? All of these eventually are areas where human orchestration really doesn't bode well for an AI adoption. So if you start looking at from that perspective, by changing your processes, you will see an ROI there.
Yeah. I did a workshop on this with a bunch of executives in Atlanta, and when I was down there, I told them, if I gave you a car that was 3 times as fast, you're not going to get to work any faster in Atlanta traffic. And I think that's a lot of what you're saying is, yes, it's a faster car, but have we redesigned the roads to get where we're going and take advantage of that speed? Um, Tapati and Ashwin, I'll turn to you both because I'd be curious, from what you've seen in the market, especially on this topic of return and value. Is it that there's not value? Is it how we're measuring value? Like, what are you seeing? What's the actual truth, and where is there variability there in what you've seen?
I think I'll take a first, the jab at it, and I think I'll just start with a very fundamental and foundational approach up here. So let's look at these three very critical words, which is architecture, engineering, and innovation. Okay, so architecture initially, I think not far in the past, but started with the digital aspect and now slowly transformed into agentic aspect. Take engineering. I think we fundamentally look at engineering that started with code and now is here with the vibe. So now I think we are, trying to deal with vibe coding as a matter of fact. And then innovation, which was part of which was included or which was considered as a differentiator, but now is a core capability. As a core approach, we all saw these three independent streams completely siloed. But now, if you look at the current complexities and the development in the tech space, all these three have converged into a very intelligent enterprise fabric. And now for us to extract the value out of it, I think we need a very strong consulting foundation.
Hmm.
And now with that consulting approach, I believe we need to find out the new human agent equilibrium, because so this is how we are going to, try to get the maximum out of our investment, because it's not just going to be human, or it's just not going to be agent. So let me take the analogy a step further, where you have a 3 times faster car, and then if you have even a better, wider roads, but without proper skill or without proper direction or guidance or navigation, you're still not going to reach your destination, right? So all these attributes play a very crucial role. But over to you, Tapti,
Yeah.
to add
And
your view.
Tapati, I'd love, especially because you've been working in AI since I think 1997. So you've ridden a few waves of hype cycles and everything, and what's worked and what hasn't, not just in the SDLC, obviously, but all aspects of AI. I'd love to, is that if you talk about this, maybe give us the historical context, because I think a question I hear a lot is it different this time? Or what's different about it too, from all of some of the previous hype cycles on AI?
Absolutely. And in fact, when I started working on AI, those days we used to call it expert systems. So that was actually what has come back now in mixture of experts, models in agentic AI, in context engineering, in generative AI. So the fundamentals have pretty much remained, but things got added, as Ashwin mentioned, in terms of the options available for different kinds of architecture in deep learning. For instance, when we talk about transformers, which is the core architecture that has made the recent AI waves, the ChatGPT moment possible, is essentially a deep learning neural network architecture, right? The attention network. So technically, we are going quite fast, and we are trying to solve the problems that are unsolved yet. For instance, the problem of less data, the problem of efficient algorithms, energy efficient algorithms, algorithms that are not the guzzlers, equivalents of cars that we have been talking so long. So those are certain areas that we are talking about, and there are waves coming which are essentially in quantum CPU, quantum computing waves. Certain kind of workloads actually will benefit tremendously from the quantum computing landscape. So that's how, in fact, over the 3 decades, I have seen AI evolve. And essentially, from an application standpoint, I think we are currently over focusing on language related knowledge automation with AI, which is what the LLMs do. But the other school of thought essentially is the robotic AI, physical AI space, where we talk about physical AI being agents with physical embodiment, the androids and humanoids of the world that can actually negotiate in an industrial environment or in a world model kind of a context. Those are the extreme use cases that we can think of that are being tried and tested.
Yeah. No, I mean, uh, very different and I think very exciting for where companies are now. You know, Raj, maybe we're recording this at the end of the year, and I think if we look back and maybe if you share a couple of the conversations you've had with folks, because you know, I remember a CTO said to us at Global Logic, my developers are all saying they're 20% more efficient. My costs aren't down 20%, and I'm not shipping 20% more. And you and I have had some interesting conversations, and even there's tooling partners we work with where one of our tooling partners said to me, he's like, you know, we have analytics on hundreds of organizations and developer velocity is almost never the problem. And I think that's the first problem we maybe tried to solve with AI was coding faster. Talk to me though about where is the actual bottleneck in terms of like end-to-end value creation versus where we're locally optimizing with AI, and how are you seeing companies start to, and how is Global Logic starting to think about that differently?
So I think, you know, 2 things. One, of course, we kind of joined the bandwagon with the rest of the industry where the whole focus was around code generation. It's our understanding now, and we have got statistics to back that comprises no more than actual 15% of the developer's time. Majority of the developer's time actually goes in planning, thinking. And what we found out also internally is that a lot of chattiness goes on between the developers, the product owners, the business analysts, the architects. And the question is, what is this nature of this chattiness? It's actually the spec. There's no clarity on it. And the question is, how well have you elaborated your spec? So it boils down exactly to the problem, which is the core, the spec. And if we were to focus entirely on the spec, I think we've got good generation technologies that can actually produce a lot of code, as well as configuration, as well as design and architecture. And that would actually yield into the ROI. So the question really is, where are we spending time on?
Yeah.
Right. And I think it is a hard problem, but it is I think the nexus of all the problems that we see in the SDLC is the spec, how well it's elaborated.
Yeah. And I think even AI aside, right, if we look at a lot of the modern product assessments that you and I have done with a lot of these companies, because, you know, we do come in a lot and we hear, hey, my developers are slow and that's my problem. And that's never actually been the problem that we found. But it is a lot of we have really poor requirements, in some of these organizations that are very traditionally, engineering tech heavy. You might have one product person for 30 to 40 tech folks, right? I think the other one that we've seen a lot too is the other end of the pipe, things, which is the other place that developers that I've heard love not to spend their time is I don't have a good, accurate QA environment. It takes forever for me to get work merged back to master and committed. The pipelines are broken. I can't get an accurate build out. I can't do root cause analysis. And so I think that's one of the interesting things I've been observing is people where we started with AI, we're kind of, we're fixing something that wasn't actually our problem. And one of the things we say is, these AI tools, they will magnify your biggest inefficiency as an organization. They're going to shine a spotlight on it. And so if you're an organization that is prone to tech debt or code that's not maintainable, AI would love to contribute to that. If you're an organization that doesn't have strong security practices, AI would love to contribute to that problem. And if you're an organization that doesn't elaborate really good requirements, AI would love to highlight that fact for you. So I think it's one of those things, if you're an organization reflecting on this, the introspective nature of needing to know, hey, this is what's not been working for us, and this is where AI is going to hit us. Ashwin, I want to pick up that thread with you because I think you talked about this interesting intersection of architecture and engineering and innovation and how those used to be separate things and now they're all kind of on top of each other. And I think even further than that, right? There wasn't a time too long ago where, digital IT systems integration were separate enough domains, but now, every project, right? It's a little bit of agile and product. It's a little bit of systems integrations, a little bit of platform integration. Talk to me about, have you seen anything companies have done or changed to help the fact that these disciplines are so, entangled, to be able to help use these tools still while making sure those systems work together?
Absolutely. I think it's very critical to understand uh, the roles that all these each attributes play. For example, let's look at augmentation versus automation. Okay. Uh, Now, if you look at the thought process, it is we need to define human in the loop versus agent in the loop approach, as explicitly for each stage of SDLC, because we have so much of expertise, or, or we have focus on those attributes, which keeps on shifting with change in problems. And everything started the conversation with, so let's have human in the loop to take a decision, but now we are shifting that to agent in the loop to take a decision. Right? So that is very critical. The second piece is the experience-led interactive designs. Now, with change in systems or change in architecture, one of the pivotal points is experience, as a matter of fact. And I think that experience component is associated with each and every interacting component. It can be a developer, it can be a consumer, it can be a system. Um, every attribute needs to be designed and defined through the lens of experience and interactive design, which usually, the focus is to to minimize the cognitive overload by ensuring agents are providing those summaries to our human the developers and those recommendations that help them make those quick decisions. And in the end, the most important aspect is organizational change management. I think, we need to start focusing on addressing the fear and resistance in adopting these agents, in infusing them in our normal workflow value chain. Because by adopting the agents in the right construct plays a very crucial role in the success of the entire value chain. And that's exactly where the ROI can see the light of day.
Yeah.
So that's my perspective. Yeah.
No, that's really interesting. I want to definitely come back. I think we're gonna spend some time on adoption and setting up the environment and everything. So I think if we look at the R of ROI, which we've only gotten one letter into the podcast so far, I think what we're saying is, we haven't spent enough time on adoption and change management. And, I think where companies are struggling is, do they have the introspection to really understand like how they need to evolve their process to be able to get that return? Now, I think the other concern that people have is the cost. And I've already heard certain use cases that you know, people get a bill and they're like, we used how many tokens on certain things in certain use cases. Tapati, you sent some really interesting articles on less is more that I think start to look at a question: is the future of AI about scaling laws, or is it about curation laws? We're pre-training to learn knowledge, but more of where companies are going to win is in the fine tuning to change the behavior of these models. Can you just talk about like what you're seeing and what people should maybe anticipate from, hey, we've given these tools, the history of the internet and everything we know, but is that always how we're going to train these things in the future? And how much data do we actually need to be able to beat some of these models potentially?
Absolutely. And I think another discussion here in US we are hearing increasingly is about the technology debt that we are eventually creating, probably without analyzing it extensively. So, if you look at the kind of processing or data center infrastructure that are being built, so typical life cycle of these technology stacks are about 2 to 3 years. Now we are planning to stretch it to at least 6 to 8 years. And we don't really know what will be the state of art of the AI infrastructure, neither from an algorithmic point of view nor from an infrastructure point of view, right? So I think there is a danger of overinvesting in current state and creating a tech debt, which will be a problem of the future. And what you mentioned, I think that's a very critical thing in terms of how do we measure the cost in the first place, right? So, are we looking at the future value? Are we really using the depreciation models that we typically use for any kind of assets, right? So, those are certain areas that we need to create, the AI infrastructure costing models in a very comprehensive manner. And I keep telling, our clients that we should look at a unique combination of AI ROI, which is a combination of F1 scores plus Sharp ratio. So we keep on talking about the F1 score, the accuracy, precision of the AI models. We don't talk about the Sharp ratio in terms of the risk adjusted returns, right? So the risk of failure, the risk of error of AI infrastructure is going to be huge. We saw it like 2 weeks back, AWS went down for a few hours and it created havoc
Yeah.
in most of the organizations and the applications that run on AWS cloud. So now you think of a remediation process for that to be an N plus N architecture, the typical BCP DRP on another cloud. Now, who's going to pay for all that, right? So, for instance, as we talk about that, a Ferrari needs a road that deserves a Ferrari. Who builds that road, right?
Right.
Who pays the price for that road? So that's where I think we take a lot of things for granted. Just imagine if you are driving on I-5 and then Google Map stops functioning, right? It creates utter chaos. I mean, nobody reaches anywhere.
Yeah.
So that's the kind of cost, risk versus value, that trade-off needs to show up in all enterprise AI use cases, be it generative design, be it in customer service, any kind of agentic software development, even. So the cost of error, the cost of bugs, and the risk of running technology debts are certain areas that we need to talk about more frequently.
Yeah. And it's interesting. This morning, opened up the Wall Street Journal and I saw this headline: Big tech soaring profits have an ugly underside, OpenAI's losses. And so I think, the other side of this, there's a lot of people that have put a lot of venture capital into a lot of these companies that are going to look for monetization. And that's going to change the price, which changes the ROI formula, which I think is coming eventually at some point. And, Raj, it reminds me a lot of, 5, 6, 7 years ago. I mean, we still see these. It was a lot of get me to the cloud. And now it's optimize my cloud costs because, there was a lot of credits given out and a lot of people, then someone started getting the bill at some point and they said, hey, did we do this right? And I think we'll probably see a similar pattern of, I
I mean,
depending on how much OpenAI charges me, I might not ask ChatGPT some of the questions I ask it a couple of years from now. I might have to go back to Googling it.
so this is not unusual, right? We've seen this with the cloud. We've seen with data. There is a fear of missing out, right? That FOMO is there. Whether you like it or not, and a lot of organizations just follow the suit, right? If my neighbor has something, then I got to have it too. And a lot of that thinking comes much later. So I think there are two aspects that I see, at least on the AI side. One, of course, is that there's a lack of understanding of what the current technology is capable of doing. I think people are trying to stretch it more than it's capable of.
Do you have an example of that?
So we know what the transformer technology is based on. And the key aspect is that there are lots of people, and I've had conversations with very, experienced folks. They think that the realm of reasoning that's in the current technologies beyond what the technology actually offers.
Mm.
If you can stick around the semantic side of it, it does a wonderful job. But if you get into the higher end inferences, which is where the human mind excels in, it fails. It fails miserably. And the question is, how much are you ready to push?
Yeah.
And our sense and our recommendation has been, when we look at, primarily from my perspective, when I look at SDLC, is to focus on areas where we think generative technologies are best suited for, which is elaboration.
Yeah.
They're wonderful at that. And using them in that capacity itself can bring significant value to the organization without getting into the part of what vibe coding can do and so on and so forth. I think there are lots of areas where people get seduced by vibe coding. I don't think that's suitable for most of the enterprises that we work with.
Yeah. I mean, I talk to a lot of CTOs that are being asked by their CFOs, how much money are you going to save next year for GenAI? And I say, that's a pretty scary question, right? And, I think, again, looking at the human element, you have a lot of people out there that now that productivity gain trickles down to somebody,
right,
but you have a lot of folks being asked to do a lot more with a lot less. And so I think it'll be really interesting seeing the organizations that, and we already saw this in some cases, right? I think we're 8 months into the prediction that there'll be no more software engineers in 6 months. And obviously there's I think still a couple software engineers out there. But I think that's one of the hard things is, are we giving ourselves time to get good at these tools and adopt them compared to when we're expecting the gains to come through? And even, one of the things that we're finding and we're learning with a lot of our clients is, these stacks, especially for elaboration and product, right? For a developer, you've got your developer interface, your code line interface, you're working in your development environment. Like your tooling is pretty consistent in an organization. And so when you build, Cursor or Copilot or something into that, it's in the tool.
Right.
With product and design, we've seen other tools that aren't integrated into Jira or Product Board or AHA. And so now we're introducing a lot more tools and we're actually proliferating information. And I had a conversation with one of our senior designers and we were talking about, if we look at Figma Make versus UX Pilot versus Lovable, like which one of those becomes a tweener solution versus not in terms of the PDLC, and how many new tools can the PDLC take? And with a lot of these tools, I think to your point around vibe coding, a lot of that is it's a very greenfield aspiration. And if there's one thing we see less of than we used to, it's greenfield for a lot of enterprises right now. So I don't know, any thoughts there, especially on the code side where you're seeing it work versus, hey, this hasn't worked?
So I think I want to give you an analogy here. Yeah. When you look at an orchestra, the conductor who conducts actually knows every nuance of the music. He's just not there to simply orchestrate. So when it comes to vibe coding, the person who drives all of that, doesn't matter whether it's with agents or humans on or in loop, doesn't matter, needs to understand the nuance of that. So the expertise doesn't go away. We're not there yet where the conductor is the GenAI.
Yeah.
Not there yet. But there is presumptions that is where things are at every role.
Yeah.
And hence, either there is an overburden or over expectation from the technology, which never materializes. But the key aspect that I see is that if you were to look into specific areas within the SDLC, break it down, you will find very specific micro roles or micro tasks that can be easily done by GenAI with a very high efficacy, but needs orchestration.
Test automation.
Test automation, classic example, or just orchestration. I'll give you one example. Let's say you are elaborating a backlog. Well, backlog there's a functional side of it that can be addressed with a PO and maybe some assistance from a business analyst, or maybe just an agent could do that. So that's one area where you could see a significant lift. But then you can also look at the same functional aspect that you could pass it to an agent to get architectural design done on it, tests generation from there. So if your specs are done well, when I mentioned spec, it's a multi-dimensional aspect to it. There are areas where you would get that lift. And when you aggregate all of that and orchestrate it well, without having these roadblocks where stories are getting generated and groomed in real time, where the AI is doing, and rather than having these wait times put in there, you will see that you could actually move towards, continuous delivery, which
Yeah.
has been the dream for most software companies.
Yeah. It's so fascinating because one of the conversations we have with folks of, are you going to put AI into how you work today? Or are you going to reinvent how you work because AI exists? And it's a tough question to answer. But I think about what you just said, and I think about writing a good spec. And I think one of the things that, Agile does on purpose is preserves ambiguity. In some case, you iterate and you learn as you go along. Now, that's not how every organization does it. But I think sometimes, Agile hides and enables teams not to have to think through a spec really well. And sometimes that leads to iteration, and sometimes that leads to technical debt, to what was mentioned earlier. And so I think it changes some of the skills you need of like, hey, if you're an organization, do you have strong orchestras or conductors in your orchestra? Or, do you have a lot of, the woodwind section, the string section, they're all doing what they want to, and they're, does it sound beautiful or not? And so it'll be interesting for organizations to think about that. Because I think that's one thing I hear from a lot of folks is we're really good at writing user stories and requirements, but can we write a really good, well thought out PRD that's going to hold up most of the way over more than 12 weeks? And one thing I see over and over again from a lot of organizations is they don't know what they're going to be doing 12 weeks from now. Like it's let's get through this next increment, and then they struggle from there. I want to shift the conversation to where we are seeing some more use cases and adoption. So, Ashwin, you mentioned change management earlier. And what have you seen in terms of maybe what companies should expect to invest in and the time it takes to drive change, and how they should be measuring adoption and thinking about this in their organization?
So, especially when it comes to change management, right? I think we need to understand the various aspects of change management. And I think it starts with the technical aspect, then the organizational aspect of change management. And so there is a lot to do with how we deal with the technical change management, especially when it comes to AI-powered tools and AI solutions. So that's a very critical aspect because we are handling curated stacks of solutions which need a completely different type of change management, especially to maintain, manage, and improvise those solutions from a technical standpoint. From an organizational standpoint, I believe it is very important for us to understand the implications of those changes on the organization, on the business, on the customer, and how will that be accepted. With the outcome of a failed organizational change management process, whereas the outcome of a failed technical change management process can be completely different, but equally impactful, right? So this is where I believe the focus on strategic partnership is extremely important, where, so I believe everything now is a multi-party ecosystem, as Raj just said. It's just not just AWS or just any other hyperscaler. So now we're dealing with a more complex generative AI environments where a hyperscaler, a platform, an engineering partner, all these three play equally important, crucial roles. And that's how a change management, which branches out into technical and organizational change management, plays a very crucial role.
Yeah. And Tapati, I'd love to get your thoughts here. I mean, I think we introduced two topics there, right? When you start talking about an ecosystem, I think one of the things that comes there is the importance of going from product thinking to platform thinking and what organizations need to do there. So if you have thoughts on that one. And then I think the other one is that comes up a lot is data and security concerns and what providers and companies can do in that space in this ecosystem. So would love your thoughts on one or both of those kind of areas as far as it comes to AI SDLC.
Yep. So essentially, from the use case adaptability standpoint, let's focus on SDLC first because that's the domain that we all are most comfortable with. So essentially, as Raj was mentioning, I think AI probably also has an opportunity to be used for identifying the opportunities within SDLC for agentification, right? So requirement specifications discovery, for instance, from legacy code modernization projects is a very viable use case for AI. For agents, for instance, multiple agents. The other aspect of SDLC that benefits tremendously from AI is testing, right? Where we we generate test cases, we generate very inclusive synthetic data, and we also kind of do an exhaustive testing. 100% of the bugs get tested during runtime, during production environment as well. So there are, in fact, big benefits to be achieved for applying checker agents and maker agents, discoverer agents for code discovery, requirement specification discovery, functionality discovery from legacy code. You look at, we people are like the dinosaurs of AI IT industry now for 30 years. When we came into the industry, we worked on COBOL, right? Now, do you get any software engineer who is comfortable with COBOL at an entry level? You don't, right? So if you give a youngster, 22, 23-year-old straight out of college, huge bunch of COBOL code and tell them to discover the requirements, specifications, reverse engineering it, hardly you will find those skills, right? So those are the areas where SDLC automation with agents make a lot of sense. And we do have curated data, curated knowledge base, curated patterns available to train these models, train these agents. The context engineering piece is pretty advanced and mature there. So I think those will be the starting points. And, once we can actually deliver the good results in terms of not just productivity, but code quality to be improved, right? Because as we were talking about that, if we automate a mess, we end up in a bigger mess, right? So first we clarify in terms of decluttered the mess. We discovered the real valuable code inside the code, inside the legacy, and then we use a translator kind of a mechanism that can produce optimized code to run on today's infrastructure of cloud.
Yeah. I love that last point. And, Raj, this is one area that you and I haven't talked a ton about, but I'm genuinely curious because I know we've tried some of these projects, right? And I think one of my questions, and I think maybe for the audience, one of their questions might be, how far can GenAI take it when it comes to code modernization? Is it great for just understanding current state? Is it, suggesting a new architecture or what the code could be? Is it writing the code? Like, where do you put a human back in that loop, and what's real and what's not? And does it change given the context of the language?
So I'm going to give you a case in point, and I think it's not your traditional example that you'd find.
Perfect.
We recently finished on a project. It's actually going on, but there is a significant part of that was done where the customer had to release a product that they've been promising their customer base for about 40 years.
I've never heard that before anywhere.
And so the language is a 4GL language called Progress. So I'm sure if you look at it, you'll find out a little bit about it. And the goal was really not to convert that into any modern language. It was actually to go from a procedural language from 4GL to an object-oriented version. So we were going from legacy to legacy. There's not enough data out there on what Progress 4GL is. So there was none of these LLMs were trained on that data. But what we found out that LLMs are great and they have this emergent properties that sort of were discovered that they're good at even writing programming languages. We were able to pull out enough information from the code base where we could have a product owner design high quality backlog without having significant contributions from SMEs. We saved about 900 hours of work.
Wow.
And using that same backlog, we were able to now generate test cases. And we brought the project back online, and we actually did the release sometime in November, early November. So here's a classic example where it's not your standard Java .NET world. You're talking about just emergent properties. We did it for another customer that had a variant of BASIC that they had written of their own. And we're running into those kinds of scenarios again and again, where customers are asking, how can you use GenAI to do something like this?
Yeah.
Because all the other ones, the semantic side of it, where known languages exist, known frameworks exist, those are, you would find a lot of examples of it. And majority of the work that we do is in that space. But there are some of these examples that truly give you the promise of how you can use GenAI from basic ability to understand language or linguistic models.
I mean, and that's a strong engineering perspective there. I know we talked about architecture earlier, but are you finding, for companies that are trying to do a monolith decomposition as well, are we starting to be able to use these tools to help us understand that, or is that still an artist area where the architect is going to have to take that further?
So here's the pragmatic choice that I give a lot of customers. Why do you want to go there?
Yeah.
So 8 out of 10 don't want to do that. 8 out of 10 are good enough with service-oriented architectures. Don't touch my database. Just give me modernization, open up the API so I can extend my capability. I can modernize that. I could use these capabilities as tools within my agentic frameworks and so on and so forth. They're least interested in saying, let's rewrite everything.
Yeah.
There are some cases where the runtime changes. We want to move away from COBOL completely because there's just no skill there. You have no choice but to rewrite. And in those cases also, sometimes a service-oriented architecture just works fine. You really don't have to go domain-driven because that is a significant cost you would have to pay. And it's still an art because two humans, given the same task, don't decompose the domain same way.
Yeah. I mean, I think that, the two examples then that you gave and the one Tapati gave earlier, I think are the three that we see people struggling with the most, which is, I feel like there's all these coding languages from the 90s that are the 90s are having a comeback and people are realizing all these coding languages still exist. And I think COBOL gets the most screen time, but I think there's other ones that, you've never heard of before and you learn it exists is one. I think this, how do I manage my monolith, to your point? And I think you hit an important point that I think in the broader technology vernacular sometimes, I think somewhere along the line, we stopped saying service-oriented architecture. We just started saying microservices, and we started treating those two things like they were the same. And to your point, the cost structure is vastly different. And I think you and I have both seen companies that went too far the other way, and now they have too modern of an architecture, and that's a type of tech debt in itself. And then I think that the last one being this kind of cloud modernization as well, and companies thinking about how do I de-risk my tech, allow for future innovation with my architecture, to Ashwin's point, while continuing to work, because there's nothing that people don't love more than parity, which is spending 2 years doing a bunch of work and I get the same thing on a new architecture is very unsatisfying for folks. So Ashwin, I'm curious your thoughts, in this code for modernization topic and what you've seen from an industry perspective.
Sure. Let's start this thought with a shift in mind from a product mindset to platform mindset.
Yeah.
So that's the core, idea that we need to live with, where we've seen API first, because now that we have a platform, we start focusing on how API drives the revolution. And let's also think through of the CI/CD of the GenAI augmentation, because that's how I believe we are going to improvise the entire life cycle, because continuous integration and continuous development of GenAI solutions or applications into your SDLC stages and phases is going to iteratively improve how you are going to define to design, and to deploy your solutions. So that's something a very straightforward approach on how we can look forward to start improvising this entire offering.
Yeah. Tapati, you started us on this track that was not planned for our conversation today. Any other thoughts or any other examples you've seen of I think both where the tools really help and I think where people have tried to put too much on the tool and we're just not there yet in terms of legacy modernization.
Yeah, and I really love the example that Raj mentioned, and because it takes us again to the fundamental of computer science in the first place, that ultimately every piece of code or every piece of infrastructure is code, right? It's the finite state automata that Turing developed, right? So I think that foundational thinking is something that whatever we have learned so far, we have trained our machines, but machines are still not able to, like, for instance, as Raj gave the example of 4GL. So 4GL existed, so the machine could discover it through logic. But if there is a programming language that is to be discovered, which will actually best fit a particular type of workload, for example, the quantum computing related workloads, right? It's a very complex protein molecule synthesis kind of very complex workloads. Uh, for those kind of complex workloads, what would be the ultimate language? Even that discovery, we are not there yet. Also because there are not enough examples. I mean, zero shot is fine, but zero shot also requires some kind of pre-trained knowledge so that in the inference stage it can learn with no examples. It can discover on its own. So in an SDLC context, in fact, I slightly differ from the, the service-oriented or microservices kind of boxing of the architecture, because I think the architecture also needs to be very agile. I really like this concept of stagility that some of our peers are talking about, where there are two swim lanes essentially, right? For all kinds of workloads, some of them require stability first, where we actually need to, like, for instance, in BFSI, if you just tell them that, okay, whatever the risk, you just keep running the transactions at speed of light, that's not a valid approach for them, right? So for a swim lane one, which is stability, we have to look at legacy code modernization use cases, which are focused on quality and risk. For the agility swim lane, the swim lane 2, we need to, where we talk about innovation, we talk about new use cases, new kinds of code to be discovered, the codes that have not been written yet, the programming languages that have not been developed yet by humans in the first place. For those kind of things, we need to look at, throwing more compute, discovery, opportunity assessment, identification of those kind of problems in the first place, where a lot of new generative AI applications need to come, right? We are still over focused on swim lane 1, but swim lane 2 are the harder problems. For instance, the ones that we do not really know yet. So those are the ones that need to be, focused on. So we should be looking at a stagility architecture going forward for AI, not putting, everything within the same box. And for certain kind of use cases, for instance, legacy modernization, there will be the fitment of the swim lane 1 stability focus. For certain kind of use cases where there are new algorithms, new programming models to be discovered through AI itself, through generative AI, those are the ones that need, service discovery kind of a new kind of architecture. Attention models were actually the starting point of it, right? But it's a long way to go. And that's where I think a lot of R&D from these hardcore algorithmic companies are going on.
I love the word stagility. So that is definitely going to be my word of the day. And I'm going to use that in the next week in a sales call. So thank you. I think that actually brings us to kind of our closeout here, which is going to be like, what do we think the future looks like here? I talked to a group of our interns over the summer, and they were asking me, career advice, especially in the age of AI. And I told them, hey, listen, don't let the job titles and the career paths of my generation define yours. Because I'm already seeing a lot of these tools enabling designers to do more in engineering, engineers to get involved in writing PRDs. And I think we're seeing folks flex. And I think one of the things I'm excited about in the SDLC is, just how we communicate with each other and how we share knowledge. I think so much when I do process optimization, I think about three processes in the SDLC. There's the decision-making flow, there's the information flow, and there's the work flow of how, requirements become code. And I think we're really focused right now on the requirements side of things. We're focused on the work, the code, the user stories, the testing. But I think how we share information with each other and how we make decisions is a really interesting area that we'll have to rethink if we really truly want to optimize the work side of things. So Raj, I'm curious your thoughts, like, 2 or 3 years from now or 5 years from now, however far you can see into the future. How do you see the SDLC being different than it is today?
To be really serious, I can't see beyond 1 year.
And there we are. Done.
But I do think there is one. I've been part of a couple of other conversations where people have asked me about what's the future of the junior developer, and my point is it's great, because if we can't, or if there is always a risk for the future generations to excel, humans are going to die as a species. So I'm never worried about the future, and because we'll adapt to it. The key aspect that I see, and it is something that I pass to everybody, is there couldn't be a better time to live. You have information and knowledge that is democratized at levels that has been unparalleled before.
Yeah.
You can bring ideas from other sides into your work. You can bring ideas that are not related to your field today and use those opportunities to create new products, new offerings, new ways of thinking, new frameworks. I think that has not existed prior to this. So I see it to be bright. In the short term, there may be some pain because people will have to change their roles and what they do. But I think that if you have an open mind and the ability to learn constantly, this is a great time. I wouldn't be worried about the future at all. We'll adapt.
Yeah, I love a hopeful message there. And I would agree. I think, you talked about where people spend their time being a key thing. And I think if all of us step back and looked at a lot of our days, how many of our meetings and how much of our correspondence and time is just overcoming, I speak a specific language and I have ideas, or I was in this meeting and I saw this thing and I'm trying to share that with you. That's what these LLMs are good at. They're good at, seeing language, learning from language and sharing that. I don't think we've adjusted to how we work yet to move away from this more bureaucratic, heavily synchronous type of work versus this, empowerment is the other big buzzword, obviously. And I think these tools do open up true empowerment. So I really appreciate everyone's time today. I think, summing up here, I think the first thing that Ashwin's talked about is, navigating, how you're architecting for the future, how you're doing your end-to-end engineering and innovation, and not seeing those things as three separate things, but an integrated system, and having the right people or the right partner that can be honest with you around what's working and what's not. And we talked about this car analogy a lot, and not just looking at the car, but thinking about the road. And so, if you're just throwing these tool licenses at the wall and hoping it sticks, that's not going to work. And so being able to have a conversation around an honest introspection on where are we getting blocked, or where does the money stop? Like if we were going to inject capital into our SDLC, where would it get stuck? I think the second thing, and the rule of thumb I've been telling people is, spend $2 on change for every $1 you spend on a license. Play the long game. Raj, I love what you said about junior talent, because I think that's something I've heard a lot. But, to give others hope, one of the things I've heard from some clients is they're hoping to do more with junior talent because of these tools, and they're trying to shift more of that work. And so I think there's companies out there that are just using their senior talent to give these tools, and there's companies out there that are, working with more junior talent to do more. We're going to see both strategies. Both sides will benefit. Will there be some short-term pain? Yes, likely. We're going to get through it like we have before. And then I think if we look at, the technology is still evolving. We talked about some of these small language models. We talked about quantum computing. There's other problems ahead of us that Tapati talked about that we haven't solved for right now. And so the cost side of this is going to continue to change. So figuring out where the return is going to be, but adjusting to what you use and how you use it, and thinking about in the long term, where is it worth investing here? And it's really solving a problem I have. And where is it someone playing an instrument versus needing a conductor for our orchestra as we go through? So I really appreciate everybody's time, and thank you all so much for being on an episode of Build What's Next.
Thank you for joining us on Build What's Next, Digital Product Perspectives. If you would like to know more about how Method can partner with you and your organization, you can find more information at method.com. Also, don't forget to follow us on social and be sure to check out our monthly Tech Talks. You can find those on our website. And finally, make sure to subscribe to the podcast so you don't miss out on any future episodes. We'll see you next time.